Hello everyone. I want to show all the 24 symmetry elements of benzene, okay, and also show all the symmetry operations, the symmetry elements and the symmetry operations of benzene. So I want us to visualize this. So our first step is to identify the principal axis. So the principal axis, as you can see, is a C6, okay. So let me indicate that. So as you can see, that's the principal axis. It passes through the center of these. So as you can see, let me indicate it this way. So that's our C6, okay, as our principal axis. Then we have established already identity, okay. So already we have two. Now let's establish a C3, okay. To C3, the moment you get to find a C3, it means you're rotating by 120. It means you can rotate the molecule also by 240 degrees, okay, either 120 anti-clockwise or 240 clockwise. It's similar. So let me visualize that. Okay, so let's visualize this. So we are saying we have the principal axis as C3, okay, but if you rotate it by C3, okay, that's rotation by C3. Okay, a rotation by C3 means you're rotating the molecule by 120. So that's the principal axis. That's how you're rotating it. It's a rotation by 120. If I rotate it by 240, which is similar as 120 in the clockwise direction, that's how it's rotating. Okay. Let's observe this. So that's how we're doing it. Okay. So it's rotating in the anti-clockwise direction. Yeah. So C3, that's C3. That's how we visualize C3. Okay. So once we have that, let's go to the C2. It has three types of C2s. So let's visualize. That's the first C2. And then, so the C2s are here. So let me visualize the C2. Remember, in our definitions, we had said C2 is collinear. C2 and C3 are collinear, okay, to C6. So we are saying, let's visualize them. The first C2 is that. That's the first C2, okay. The second C2 is that. The third C2 is that, okay. So that's how we perform that. We can see another C2 double prime that way, and also that way, okay. It has an inversion center. That's how we visualize the inversion center. It has an S3. We can indicate all of them. Let's just indicate. So as you can see, that's an S3. Okay, so this is an S3. That's the S3. So it's a rotation then by reflection. Okay, so this is a sigma H. So that's a reflection. Also, let me indicate the center of inversion. Center of inversion, that's the center of inversion. And then we are having C6, S6. Sorry. So we're having an S6. So that's an S6. And then let me remove this. So an S6, that's an S6. Sigma H, that's our sigma H. As you can see, that's the sigma H. It cuts the molecule halfway in both sides. Yeah. So it has a sigma D reflection, the dihedral plane. As you can see, we have three dihedral planes. Okay. But let's visualize it one after each other. So let me unmark that. So we are saying the first dihedral plane, that's the first dihedral plane. Okay, that's the first dihedral plane. And then that's the second dihedral plane. Okay, so the third dihedral plane, that's the third dihedral plane. And then also we are saying it has 3 sigma V's. Okay, it has 3 sigma V's. So I want to indicate the sigma V's. So the sigma V's are here. So let's indicate them one by one. So it has the first sigma V as these. So let's indicate that. So that's the first sigma V. That's how you visualize it. That's the first sigma V. Okay. The second sigma V is that. This is the second. This is the second sigma V. The third sigma V is that. So we have tried really to show the operations that you can do. We have tried to really visualize these operations. So that's all we have for this benzene. It has 24 symmetry elements. Okay, so that's all for this video. This marks our end of this video. So please like, share, and subscribe.